Question 2. Recognize physical quantities like time, mass, temperature, volume, density, and classify them into base and derived quantities, and specify the dimensions of each quantity in the SI system of units. The base quantities and the base units are as follows. We have 7 base quantities that we can formulate any other quantities from. These 7 base quantities are length measured in meters, mass measured in kilograms, time measured in seconds, temperature measured in Kelvin, amount of substance measured in mole, electric current measured in ampere, luminous intensity measured in candela. So these are the 7 base quantities in physics, and these are the units used to quantify them. For example, the length of the door is 5 meters. The mass of the book is 1 kilogram. The time takes me to get ready for school is 1 second, or let's say it's 100 seconds, or 1 hour. But here, the base quantity is seconds. The temperature of the water is 100 Kelvin, and so on. So these are the 7 base quantities and the 7 base units used to quantify them. And these are some measuring devices used to take the measurements of these quantities. Now, derived quantities are the quantities that are found by applying formulas that contain base quantities. For example, velocity is equal to distance over time. Distance and time, both of them are base quantities. Distance being similar to length, and time, well, is the same as time. So velocity is equal distance over time. Applying this formula with base units or base quantities, you get the derived quantity velocity. Now, derived units are units that are formulated by combining the base units in various ways. So for this example, we can find the unit of velocity by dividing the unit of distance over the unit of time. Distance being measured in meters and time being measured in seconds. That makes the unit of velocity meters per second. So substituting the unit of the base quantities in the formula gives you the unit of the derived quantity. There are some derived quantities that you have to memorize, being volume and density. These are some derived quantities. Volume is measured in meters cubed. Area is measured in meters squared. Density is measured in kilograms per meter cubed. Velocity is measured in meters per second, which we just found out. Acceleration is measured in meters per second squared. Force is measured in kilograms meters per second squared. And pressure is measured in kilograms meters second squared. Now you need to memorize the derived quantity, volume, and density, and their units. For volume, it's measured in meter cubed, and density is measured in kilograms per meter cubed. Let's see how we got these two units. Of course, sometimes sometimes the derived quantities can be expressed in easier symbols. For example, for force, you can see here that the unit is kilograms meters per second squared, and that's a long unit. Sometimes we express these units, long units for derived quantities by simpler ones. For example, kilograms meters per second squared can be given the symbol N for newtons. So 1 newton is equal to 1 kilogram meters per second squared. Similarly, pressure, which is measured in kilograms meters second squared, can be given the unit PA or Pascal. Similarly, charge, measured in ampere seconds, can be given the unit coulombs, C for coulombs. See that these are the names of the scientists that defined these quantities and formulated them to a formula to be able to calculate it. So again, for force, the unit is kilograms meters per second squared, or can be expressed by newtons. Pressure can be expressed by Pascal, and the charge can be expressed by coulombs. Now, how did we derive the units? We derive units by substituting the base units in the equation. So for example, if you know that volume of a cube is calculated by V, volume, equals L, length, times W, width, times height, h. What is the unit of volume? Now we know that length, width, and height, they all have the base unit of meters. So if we substitute meters instead of the length, meters instead of the width, and meters instead of the height, you can see that I'm multiplying meters 3 times. Meters times meters times meters gives you meters cubed, which is the unit of volume. Now, if you know the density is calculated by density equals mass over volume, what is the unit of density? Now we know from the list of base units that mass is measured in kilograms, and volume, we just found the unit of volume to be meter cubed. So substituting these units in the density formula, mass we will substitute kilograms, and volume we will substitute meters cubed. You can see that the unit of density is kilograms per meter cubed.